Yeah, good morning, everyone. Let me add my welcome to you this morning. It's great to be here with you. This is only my second time at the Scottish Conference, so it's going to be a great day. And I'm joined on stage by Richard here and Laurie. We've got some fantastic content powered by ArcGIS 2024 for you this morning, and they are going to come in at points along the journey and really bring this story to life. Now, as CTO of Esri UK, one of the things that I obsess about is the future strategy and direction of our technology. And today, I don't think you can do that without considering the question, how does AI affect the realm of GIS? Now, I don't know about you, but I only need to open my phone to be inundated with the news articles, the opinion pieces, and let's face it, the relentless amount of AI-related spam that arrives in my inbox. Frustrating as some of that can be, though, I do genuinely think it shows that we are living through a time of exciting technical innovation. And you'll have seen tech commentators and visionaries describing AI as the biggest technology revolution since the cloud or the internet or even the graphical user interface, the air we breathe. You know, you can pick your comparator, say it with conviction, and nobody's going to disagree with you. Well, I'd like to bring a little bit of balance this morning. Behind the stories, have you also seen some of the other stories and challenges that we have in AI? Things like, what about data privacy and security? Or what does it mean for intellectual property when these algorithms are trained on our data? Or how about this one? Have you seen how AIs have been shown to reinforce societal bias and stereotypes? See, behind the hype, there are some genuine hurdles for us to overcome in this space. So how do we do that? How do we make sense of the role of AI within the realm of GIS when we have all of this exciting capability and these things that can really help us with, and yet we have some of these challenges as well? Well, one of the ways that I like to do this is to make it real. And today, we've deployed AI inside the ArcGIS system in two ways: GeoAI and generative AI. Now, these areas aren't necessarily mutually exclusive. They can overlap, but I think the distinction is helpful for us just as we explore this together. GeoAI, then, is the application of AI techniques to help us solve geospatial problems. And today, and for many years, within the ArcGIS system, we have deployed traditional AI approaches from the fields of computer vision, for example, machine learning and deep learning, to supercharge our geospatial analysis to help us to do things like object detection and classification and feature extraction. Generative AI is really what's come to the fore and made the headlines over the last few years. It offers us techniques to generate varied and lifelike outputs in creative domains, things like images and video, poetry and music. And these things are often indistinguishable from human-generated content. And the future, I think, is where the overlap starts to come. I fully expect the realm of generative AI to fundamentally influence and change how we do GIS and how we do GeoAI. So, how are we getting on with that? Well, we've started at Esri to deploy generative AI approaches inside the ArcGIS system to simplify and expand access to GIS and to help you increase productivity through the use of AI assistants. Now, these assistants expose natural language interfaces, which means that we can ask them simple questions. And I think this really starts to serve two different audiences. The first is about simplifying access to geographic information. It's about taking what we have and exposing it to a whole new audience of people who have previously been unable to interact with it because it's been too difficult, too complex to understand, and the experience and the training that they might have needed, they didn't have. We can use natural language interfaces to help these people ask simple questions and drive really complex technology and complex algorithms to get answers. The second audience is you. It's the GIS professionals of our community. You know, you are the people who are driving software hard, who are highly skilled, highly trained, and have been working with this technology for a variety of time periods. Maybe you're very new, right through to many, many years. But actually, AI assistants can help you as well, because if we can help you to ask simple questions that have really complex processing, then that helps you to do more, to be able to start to orchestrate and coordinate those outputs rather than having to hand crank all of that work directly. And when we stand back from it, what we're really trying to do is two things. We're trying to simplify access to GIS, make it easier to use. And we want to expand productivity, help you to do more. So let's start to take a look at some of this in action. I'm going to hand over to Richard, and he's going to bring some of this to life for us.
Thanks, Mark. Good morning to you all. For the next 10 minutes, I have the pleasure of giving you a preview of how generative AI is being integrated into ArcGIS. Mark has warned us AI might be overhyped, but I'm going to predict it will still impact the way you work. The first demo I have for you is Esri's form-centric application, Survey123. This is actually my favorite app, so I'm delighted to be able to share with you some awesome new features. I'll keep the identity of the second product a surprise for later. AI can assist us in a variety of ways. Earlier this year, we released the first incarnation of the Survey123 assistant. One of its abilities is that it can mimic holding a two-way interaction with you by understanding and responding in text to generate a form. You may have seen a similar demo before, but hold tight, I'll get onto some new stuff very soon. Linking back to the talk Nature Scott gave earlier, pretend you are tasked to manage a data capture project, focusing on a biodiversity study. You've chosen Survey123, a wise choice, but you haven't used it before and don't know where to start. Well, the Survey123 assistant can help here, as it will work with you to generate a basic form in no time at all. When you are starting from scratch, the Survey123 assistant icon appears in the bottom left. I give it the following prompt using our earlier example. Create a biodiversity survey recording surveyor, date, location, photo of wildflowers, and species of wildflowers. It understands the request, and after a little think, it returns the basis of a potential survey. It's got a lot of the questions we need, but some aspects can be tweaked. I decide I would like a land use question, and also the location question could be modified. So I'll reply to the assistant. Add in a photo question to record a site photo. Add in a text question to record the land use of the site. The assistant is able to take this feedback on board and reply with a new survey structure. We can see our questions are added as questions 6 and 7. This will meet our requirements, so I ask it to generate the survey form. What happens next is this text is converted into a survey form, which can be edited in the web designer. I could add in new questions here, but the main change now is I can customize the properties of each question. Here, I'm auto-populating the surveyor name and setting the visibility to hidden. Here, I'm making the submitted date the default and marking it as read-only. Both of these changes will improve the user experience, reducing the number of questions needed to be filled in. Now, as promised, I'll show you something new. To generate the land use type, I'm going to configure its calculation settings and extract data from a previous question. What I'm going to do, though, is select the photo question. You may wonder what data I could extract. Well, I'm going to call on the help of the Survey123 assistant. We have given it a new capability to generate answers to questions that relate to a photo. You simply enter a question asking what data to extract. This is really cool, and it's an example of how generative AI can benefit the more experienced GIS users. Like setting the visibility of fields, it also acts as a tool to make the survey easier for the end user. I'll show you the prompts I've used in a survey I prepared earlier. In working with Nature Scott, we learned how it's important that people are not identifiable in their images. I can ask the assistant, are there any people in the photo? To record the land use type, I simply ask the assistant, what is the land use in the image? At the end, remember, I have a question to collect the species of wildflowers. I don't want to create a long drop-down list of all possible species. Instead, I can simply ask the assistant, What wildflowers can you identify? How easy was all of that? Let's see it in action. This survey looks very clean and will be simple to use because all the questions feed on from one another. To begin the survey, I simply upload an image of where we will be conducting the biodiversity study. The location is taken from the photo GPS metadata. Let's just pause to think what we could expect the next two questions to be. I asked it, are there any people in the photo, and what is the land use? I would expect it to reply with, yes, there are people in the photo, and that is a park. The AI questions currently say analyzing image, but the assistant is very quick. For the first question, it is indeed recorded there were some people in the image, so this can't be used in any publication. The AI has determined the land use to be a public park, which is correct. If I say there are wildflowers and I upload a photo, we will see what flowers it identifies. In this case, poppies, cornflowers, and daisies. If you're wondering, I have tested asking the assistant to return the Latin scientific names, which it did perfectly, but I didn't want to embarrass myself trying to pronounce these in front of you today. This demonstrates how powerful this technology is, and there are many potential uses for first-time users as well as hardcore fans. Using AI here has in essence supercharged my survey, making it easier to both create the form and submit responses. Although I could spend all day talking about Survey 123, I'm excited to show you something new and not currently publicly available. Yes, I've been fortunate enough to have been provided access to the ArcGIS Online organization, where we have built in a new smart mapping functionality into the map viewer. It's called the Mapping Assistant, and it provides an interface that allows you to style feature data in Map Viewer using natural language. Let me jump straight in and show you it in action. I have added in the Scottish Index of Multiple Deprivation dataset from the ArcGIS Living Atlas. This is a dataset published by the Scottish Government that is a relative measure of deprivation across almost 7,000 small areas across Scotland. Each data area is scored against multiple measures of deprivation, but this map is not showing anything. I will show you how you could use the Smart Assistant to remedy that and paint a picture of your data. I know health is one of the deprivation categories, so I asked the assistant to generate a map by health rank. The assistant is clever. Health rank is not the specific name of a field alias, but is able to identify the required field from the attribute table. Whilst I was talking, we saw the assistant was working on the task, but it didn't take long, and once finished, the style of the layer was automatically updated. Remember, my prompt only asked to generate a map by health rank. I didn't specify the values that make up the color bands. The assistant was able to look at the data and generate a style that it felt was most appropriate. If I had to complete this task, it would have taken me much longer to look at the data and make a decision on the appropriate bands. The neat thing is, the assistant generates a card for this. No more clicking through a series of drop-downs, dialogues, and buttons. By clicking the card, I'm able to customize the symbology as I see fit. Next, I will demonstrate how the assistant does with a different style. Rather than a choropleth map, let's ask the assistant to map something else. I decide I want to map crime rank, but by dot density. So let's ask the assistant, generate a dot density map of crime rank. Again, we see the assistant understands the prompt, and after not too long, updates the map and generates a card for us, where we can again customize the style properties. For one final task, I will try something more tricky. Not everybody knows this, but it is possible in ArcGIS Online to map the relationship between two fields. It is what is known as a bivariate map. It would help to answer the question, do areas of low employment also have areas of low education? So let's ask the assistant to create such a map. Show me the relationship between education rank and employment rank. Wow, that's certainly an interesting map. The Map Assistant hasn't replaced us. It's done the initial work, and it's been a great tool for us to now concentrate on further inspecting its output and drawing out any conclusions. I'm excited to see this type of analysis being used more and more in the future. This is probably the best example of how this functionality will make it incredibly easy for people to engage with complex technology. Not only does it provide inspiration, giving you ideas from nothing, it also streamlines workflows. All of this lowers the barrier of entry, which is also important in our industry. Thank you, and back to Mark.
Fantastic stuff. Thanks, Richard. And I'm sure you can see there, Richard really unpacking those two focus areas. Some of that was about simplifying access and being able to generate that survey with real simplicity in those natural language questions. But some of it is about expanding productivity and helping professional GIS analysts and other GIS professionals to be able to do more. In fact, these two areas of focus for us have been significant over the last year or so. And using AI is not the only approach that we have taken for these purposes. Earlier this year, we also changed and simplified our named user type access model, our licensing model to ArcGIS. But we did that for exactly the same reasons: to expand the access to capabilities that you have, and also to simplify how you get that access. And really, I want to say thank you to you as a community for your input and feedback here, because as I work with organizations and as I work with users, one of the most common pieces of feedback that I've heard is that ArcGIS licensing can be difficult to understand. It can be complex. And we really wanted to change that. And so earlier this year, we simplified access to the ArcGIS system to the 6 user roles that you see on the screen here. And then we expanded out the capabilities that you have within these roles, adding in more applications and more capabilities at each level. Now, what this also means is we've simplified the whole ecosystem of our applications and access to them, because by bundling in all of this new capability in with these 6 levels, we have removed many, many of the other ways that you can previously access these applications. And that means that understanding our whole licensing model should be a lot simpler. Now, I like to think of it as we're moving away from licensing individual products and applications, but we're moving towards enabling you as individuals. And if you're an individual with one of these roles, then that gives you access to a set of capabilities. And that set of capabilities is delivered now through a portfolio of apps that you now have access to as part of that role. So, if our role gives us access to capabilities, what are some of those capabilities? Well, as Richard showed in that last demo, it all really starts with the ArcGIS Living Atlas of the world. It's the world's largest collection of maps, of demographic information, of near real-time content, of pre-trained machine learning models that you can plug into and use directly. And at Esri, we actively curate the Living Atlas for your use. But it's not just content from us. It's also authoritative data sets from our partners, from the organizations that you represent, and from the wider community. And then as users, what we do is we take this content and we build it into beautiful and compelling maps. I like to think of mapping as the language of geography. It's how we convey spatial information to one another. And as we do that, as we communicate with one another, just generally, we do it in the realm of telling stories, don't we? And ArcGIS has a powerful set of applications to enable you to tell those stories in creative ways. And as we do that, and we map objects and locations where things are, and we look at the patterns and the interactions between those different objects, we start getting into the realm of spatial analysis, which is really about extracting knowledge and uncovering patterns using geography. In fact, this is also what data scientists do. They mine data to extract information, and ArcGIS is a platform that spatially enables data science. We also have tools to address the spatial analysis of big data, and using ArcGIS Geoanalytics Engine, we can take the power of spatial analysis and point it at existing Spark data stores, which means we don't need to load that data into ArcGIS first. In fact, we've been working with Microsoft on this exact approach, taking our big data spatial analytics tools and embedding them into Microsoft's new enterprise analytics platform, Microsoft Fabric. Why is that exciting? Well, once again, this is about expanding access to GIS. And Microsoft themselves have a user base of a billion users globally. That's 1 in every 8 people in the world. And we have an opportunity to improve spatial awareness and enhance spatial literacy by providing access to spatial analysis techniques natively within that system. We also have tools for link analysis and visualization. So this is about integrating knowledge graph capabilities with ArcGIS. Knowledge graphs help explore the relationships between entities and how they are connected. These sorts of techniques are common in things like supply chain mapping and crime analysis. And for the first time, with the changes to the user types that I spoke about, we have enabled this capability for creators, for professional and professional plus users of ArcGIS Enterprise once you have that server extension. Data management is about modeling the behaviors, the interactions, the relationships, and the attributes of data in very specific contexts. Now, at Esri, we've built services-based modern industry models to allow you to do that in very specific areas, like modeling utilities data, for example, or transportation data, hydrology, and lots of other areas. And you can imagine, if you can model those specific contexts very accurately, the power that we have when we start to bring that together, all of those areas together, and hydrate and enrich our digital twins environments that help us to understand how the natural and the built environments collaborate and work together. We've got comprehensive field operations applications. Here we have our flagship application, ArcGIS Field Maps, for really managing a mobile workforce at scale. You've already seen today Survey 123 in action that Richard showed. That's our forms-based application for data capture. And we also have Quick Capture for capturing those sets of rapid observations. Real-time visualization and analytics is about the tracking, monitoring, and alerting of continuously changing data. And we live in a world where sensor networks and IoT devices are just proliferating rapidly. And we're seeing real-time information really as a core part of building and operating digital twins that are being operationalized in production in some sectors, for example, transport. ArcGIS is a 3D system across the whole system. And really, we're seeing 3D analysis coming to the fore here, not just visualization, increasingly supported for 3D editing as well, and also immersive experiences. Kamal talked earlier about game engine technology. These are environments that help to bring real geographies to life with animation, visualization capabilities, physics engines as well. We've also seen the imagery and remote sensing community really explode over the last few years, with access to remote sensing techniques becoming increasingly democratized, access to things like LiDAR sensors increasing, which is really driving more and more data products in this space. And you can use ArcGIS to analyze, visualize, and store, as well as share these information products. And it's the coming together of these last two areas, talking about 3D and remote sensing and imagery, which has really fueled this new area of reality mapping with easy access to drones and satellites and sensors, as I spoke about. And at Esri, what we've done is responded by building ArcGIS Reality to really support organizations that are fueling the GIS and the digital twin communities. So you might have seen there, as we've walked through the capabilities of ArcGIS, that actually many of them are being used today to help build and operationalize digital twins. And so to bring some of this to life, I want to hand over to Laurie.
Flooding poses threats to both human and environmental well-being. To try and understand and mitigate the impacts of flood events, flood simulation tools are crucial in helping to determine how and where water will flow. The new flood simulation tool, available in ArcGIS Pro 3.3, uses shallow water equations within a defined area of interest to model how water moves and accumulates within a scene. The tool is easy to use and provides fast, on-the-fly visualization of results. You can create a scenario and review the results, You can then easily adjust the parameters, such as increasing the amount of rainfall to see what impact this has on the outcome. This makes the tool applicable to a wide range of use cases, including disaster preparedness, urban planning, and infrastructure resilience. In today's demonstration, I'd like to show how we can use this new capability to simulate a possible flooding scenario. We'll then try adding in some mitigation measures before rerunning the simulation to see if this reduces the potential flooding impacts. To use the tool, we need to start by opening a 3D scene in ArcGIS Pro, like you can see on my screen now. For this demonstration, you'll see that our study area will be focused on Fort William on the west coast of Scotland. Now, before we run our flood simulation, we need to start by creating our digital twin. When running a scenario, all layers that are visible in a scene are by default included in the creation of the elevation surface upon which water flow will be modeled. Our first step, therefore, is to decide which layers we would like to include. We'll start by defining the elevation surface. By default, the ground surface in an ArcGIS Pro scene is defined using the World Elevation Service from the Living Atlas. This service contains data from providers around the world and includes data of up to 1 meter resolution for parts of Scotland. You can optionally choose to define your own custom elevation layer if you wish, but for this demonstration, I'll continue with the default option. Now, we'll add any 3D layers that we'd like to include in our digital twin. I'd like to include some buildings in my scene. To do this, I'll select one of the 3D base maps available in the ArcGIS Living Atlas. All of these base maps contain buildings data from the daylight map distribution of OpenStreetMap. Previously, adding this buildings data in required me to find the particular dataset, so I love that I can now add this to my scene in just one click by selecting a 3D base map. Having added this data, we could choose to add additional layers should we wish. For example, we could add some of our own datasets, perhaps such as proposed future developments. For this example, however, I'll continue with the data that we currently have. By leveraging datasets that are readily available from the Living Atlas, we've been able to create a 3D scene of our study area. The Flood Simulator tool will then take this rendered view to generate a height map upon which to model water flow. I hope this shows you just how quickly and easily you can get started with datasets that are ready for you to use. With our digital twin complete, we're now ready to create and configure our flooding scenario. To get started, we'll select the Analysis tab, click the Simulation option, and then from the drop-down, we'll select Rainfall. We're then prompted to define the area of interest within which our simulation will run. I'll define this using a rectangle that I can draw interactively. With that done, I can click Complete, and we can see that a new simulation layer has been added to our scene. You'll notice that a new Simulation tab is also added to the top ribbon. We now need to configure our scenario. To open the configuration pane, click this button from the top ribbon that my cursor is currently circling. We'll start by defining the duration of the scenario and the rainfall through time. For this example, you'll see that I've set the duration as 30 minutes, with rainfall being applied at a rate of 50 millimeters per hour. The rate can change over time if required, with rainfall being applied equally over your area of interest. We can then define other properties of our simulation. From the top ribbon, we can insert channels, water sources, and barriers within the area of interest. From the configuration pane, we can define properties such as the initial water depth, for example, by starting at the 100-year flood event state, and infiltration rate. Both of these can be defined as either flat values across the area of interest or as rasters, which allows you to spatially vary the values and link these rates to properties such as soil type. With the configuration of our scenario complete, I will click Run. Once clicked, the 3D view is converted to a height map, and the water flow simulation is run. As our scenario progresses, we can see the results being displayed within our scene. You'll notice that water is flowing down the steep hillsides and accumulating in channels, particularly here in the River Nevis. When the simulation has finished running, we can use the back and forward arrows in the top ribbon to move through time and explore our results. Now, one of the great features of the flood simulation tool is that because it's so quick and easy to run, and the height map is only generated from layers that are visible, it makes it very simple to simulate alternative scenarios. For example, we can see how water flows may vary under different amounts of rainfall, or explore how new developments may impact results. If we zoom in to this part of our study area, we can see that the results are suggesting that as water flows down these rivers, it's going to overflow and go on to flow through this housing estate here. If this happens, it looks like quite a number of properties could be affected, so I'd like us to consider how we can reduce the risk of this happening. Within the flood simulator tool, we can add barriers to try and divert the flow of water. To do this, from the top ribbon, we'll select the barrier element, we'll define the height and the width, and then we can digitize the barrier's path. Once complete, we can see that our barrier element is added to our scene. When we now rerun our scenario, this additional element is taken into account when the height map is generated. And as a result of this, as the simulation progresses, we can see that the water now flows differently. Adding this barrier has certainly helped to reduce the amount of water that flows through the housing estate. However, if we zoom out, it appears to have caused further flooding downstream. If we wanted to, a next step for us could be to adjust our barrier configuration and then rerun the scenario to try and find a more optimal solution. Now we've finished running our simulation, we can export our analysis results as a raster dataset using this button in the top ribbon. We can export datasets for water depth, absolute height, and velocity, and we can set the time interval of our export. Having exported the data, we can then load it into a mosaic dataset to step through and identify values through time. Here, we can use the temporal profile charting capabilities in ArcGIS Pro to explore how water depth is simulated to vary over time in a particular location. Using the ArcGIS online imagery capabilities, we can also publish this data so that members of our organization can view our results via web maps and web apps. Here, we can symbolize the water flow using an animated flow renderer, which allows us to really nicely visualize how water is simulated to flow. On the left-hand side of the slider, you'll see the results from our original scenario, whilst on the right are our results with the barrier in place. As I drag this slider, you can clearly see the impact that this mitigation measure has had on the flow of water. I hope this has given you a really informative introduction to the new flood simulation tool in ArcGIS Pro. As we conclude this demonstration, here are 3 things to remember. The tool uses simplified mathematics, which makes it suitable for geodesign, but not engineering. The simulation is based on the rendered 3D view in an ArcGIS Pro scene, and the tool provides a quick and easy way to simulate and visualize different scenarios. We look forward to seeing how you will use the flood simulation tool within your workflows. Thank you, and back to you, Mark.
Thanks very much, Laurie. And you can see there how Laurie started with a blank canvas, started to build his digital twin, and then crucially ask those what-if questions, simulate different scenarios to help us make decisions in the real world. So we've looked at a lot of capabilities today within ArcGIS, and at Esri what we do is we build those capabilities into applications that we specifically design to support different types of work. And then we bring that all together in the ArcGIS system, which is really comprised of 4 pillars. Firstly, we have a desktop software pillar where we have ArcGIS Pro, our professional desktop GIS and data science workstation. We've specifically designed Pro to work with local data, to connect into ArcGIS Enterprise and ArcGIS Online for that collaboration, sharing, as well as to work with OGC services. Secondly, we have our server software pillar, ArcGIS Enterprise, which is GIS infrastructure for your organization. You can deploy Enterprise on premises or in the cloud, and it comes with all of the capabilities that I've spoken about today. And we're seeing increasing interest on ArcGIS Enterprise on Kubernetes, which is a cloud-native deployment option of ArcGIS, which provides you some additional benefits, things like scaling agility, things like strong DevOps support and automation. And it also comes with a licensing model that's based on users rather than on cores, which gives you that ability to scale really easily. Thirdly, we have our SaaS pillar, where we have ArcGIS Online, the world's largest mapping and data sharing ecosystem. Now, today, many of the capabilities that I've spoken about are available within ArcGIS Online as SaaS, and we're continuing to focus in this area and bring more capabilities into SaaS because it lowers the barrier for entry and it provides access to wider audiences at simpler points of entry. And a good example of this is we just saw Laurie show how to share his analysis in the imagery tools inside ArcGIS Online. A few months ago, that was called ArcGIS Image for ArcGIS Online, and it was a completely different licensed option. But with the changes to user types I spoke about, we've now enabled that as a core part of ArcGIS Online for creator users, professional, and professional plus users. And fourthly, we have our PaaS pillar, where we have ArcGIS Location Platform. What this really does is it takes everything that I've spoken about today, and it addresses the needs of developers by providing access to ArcGIS via an API with a simple and clean consumption-based business model as well. So they're the pillars of the ArcGIS system, and really they're all brought together centrally by the portal. The portal is at the heart of the system, and it provides its capabilities of its own, things like identity and security, the ability to do content management, secure sharing, collaboration. Now, there's a portal available in ArcGIS Online. There's a portal in every deployment that you make of ArcGIS Enterprise. You can connect into it with ArcGIS Pro, and you can build apps for it with Location Platform as well. So there we have it, the ArcGIS system. We have spent this year really focused on those two areas that I spoke about earlier, simplifying access to GIS and helping to expand productivity. And similar to how you fed back on user types, I'm really interested in hearing your feedback on this. So please do tell us how you're receiving it, how you're using it, and I look forward to having those conversations with many of you throughout today. Thank you.